Okay, I'm going to explain about a study case for virtual worlds. Here, let's consider a simple system with a uniform rod of length L and weight hinged at one endpoint, at point A, and held in horizontal equilibrium by a string attached at the other endpoint, and making an angle with the horizontal determine the tension T in the string. First, we define the free body diagram for this situation. Free body diagram helps us to visualize the situation, which is it makes easier to solve the problem. So imagine we have a beam in length of an L and is being given an external forces over here. We call it weight. It hinged at point A, which is having a pin support because and then it's also hinged with a flexible cable at point B and made an angle with the horizontal equilibrium. So in here there is a theta. So the situation, this is the length of L, right? Length of L. Okay, it's given an external forces on way. There is a movement in this beam. Imagine we have this displacement, and then what happened to the beam? Okay. All right. The case is asking to determine the tension T in a string. So this is the tension T in a string, which is, if you realize, because it's point A and it's point B, there is displacement right on B, right? From here, it's moved to here, right? So because of that, it happens on Y, so there is a displacement on Y on point B. So there is a length, the whole beam length, and there is the displacement of theta. I mean the what is it called? The angle. And then after that, if we already define, look at this displacement that happened over here. The beam has displacement because of an external forces. We call it weight. Weight itself has its distance from A to weight. We call it L per 2 displacement theta because there is also a displacement in here. This is for displacement on X. Okay. Now, how to solve this kind of situation? First, we have to define the virtual works done by external forces and weight of weight. Okay, so virtual works by external forces. Okay, virtual work by external forces that we define at weight, and also in here there's a tension. So the displacement because of the weight, the external forces, is minus minus W, which means in here the vector is downward through an y-axis, and then in here weight, the distance is L per 2 displacement on theta. That's for the weight. What about the tension? So for the tension, displacement on tension. In here, tension also has the displacement. The length of the what is it called? The length of the beam is L, so L, right? Call it L. Displacement on theta. Don't forget there is a sin theta. Where does it come from? Sin theta comes from the situation which is on beam. We have known that the angle is on the horizontal or on x-axis, but what we define is on y-axis. So we have this sin theta. Or the situation also same situation as this, what we already talked about before. Okay, after this, then we have to do the principle of virtual works, which is everything has to be in equilibrium situation, which is sigma f equal to 0 and sigma m is equal to 0. So everything that happened in here has to stay in equilibrium. So the how to solve this problem is we already have that statement. Wait a second. Let's move this one to here. Okay. Now we already have the now we already have the situation. We define the principle of virtual works. So what is the principle of virtual works? So the notation that we already have last time, the displacement on weight and plus displacement on tension is equal to 0. So we have this minus L over 2 displacement on theta plus T L displacement on theta times sin theta equal to 0. So mean W L per 2 plus T L, right, sin theta. It's because we cross the displacement theta, so we have this notation equal to 0. Now we calculate this where L per 2, right, plus TL sin theta equal to 0. Okay, TL, because the one that we are looking is the tension, so we focus on T here. TL sin theta equal to L per 2. Okay, T equal to L per, so it's moved to here L sin theta times 2 equal to T coret W per 2 sin theta. So this is the result of the principle virtual work that happened from these study cases. See you at the other cases. Thank you.